This is Radko Kadem, and welcome to this video. In this video, we'll be looking at carboxylic acids, and this is under organic chemistry, and this is a grade 12 way. So if you're watching me for the first time, please make sure that you do subscribe to my channel so that you don't miss any updates. So make sure you subscribe. So let's dive into that. So we'll be looking at carboxylic acid. So we know that carboxylic acid, when you're looking at them, this something that we need to understand is organic acids. Okay. Now remember, organic acids, they have one of the characteristics that once you put them into, you pour them into litmus paper, they turn the litmus paper to red. Okay, so they turn the litmus paper to red. So then they are also weak acids, meaning they do not dissociate completely into water. So they do not dissociate, okay, sort of like to dissolve, I may say, dissolve. So dissolve into water 100%. Then the other thing is that found in plants. So e.g. apples, as well as vinegar. Okay, so that is sort of like the basic and summary of that. Okay, so now what is the general formula? What is the general formula? Okay, so the general formula is CN H2N and O2. Okay. Sometimes some other people they normally don't include the O2. Okay. So you can even see CN H2N COO that. Okay. Now this part is normally called the functional group. The functional group. Okay. So the functional group for the carboxylic acid is called carboxyl. Okay, it's called a carboxyl group. Okay, now when you talk about the general formula, we are looking at the formula that can help us to generate other specific carboxylic acid compounds in this family. So when you look at their names, they ends in O-I, then acid. Okay, so ends in O-I-C. Now what this means is that you are looking at something like if I have, for example, meth, okay, meth means one atom of carbon. So if I have what is called methanoic acid, then I know because it's ending OIC. And then I can also have another one called ethanoic acid. So you can see right there. You can see that it ends in the 3 letters OIC. And then I can have propanoic acid. And then I can also have, let's say, the last one, butanoic acid. Okay, so butanoic acid. So you can still go and continue, but before you get an exam, you need to at least know up to the 10th compound. 10th compound. But for the simplicity sake, let's just focus on this, okay? So now when you have that, then we can develop the formulas, okay? The molecular formula for each one of these. Now, how do you come up with the formula? So you always need to use this formula, okay? Now, what this means is that if I have, for instance, methanoic acid, then I'm going to say the number of carbon equals 1 in this, and therefore from this general molecular formula it's going to be like this, then O2. Okay, so what this means is that where there is N, I'm going to put this 1. So C1 H2 1 O2. Okay. Now when on the carbon this number is 1, just ignore it and just say 1, or just say C, then 2 times 1 is saying 2 times 1 equals 2. So this is going to be 2, then O2. Okay. So now we can write this one properly. It's going to be, first of all, start with the functional group, which is COO. Now this functional group also, the carbon is part of this. Okay, so make sure that this carbon, one carbon that we have is this one. Okay, and then the oxygen, the 2 oxygen that we have, they are this. Okay, and then the hydrogen is also part of this. So the only thing that I'm going to add here is just to add this one. So this is the molecular formula for methanoic acid. So I'm just going to say HCOOH. Okay. And now for ethanoic acid, I'm going to do the same. Okay. I'm going to do the same. So ethanoic acid. So eth means 2, therefore our N equals 2. So what do you do to come up with a molecular formula for ethanoic acid? So first of all, know the general molecular formula, which is CnH2n, then O2. So where there is N, I'm going to put 2, okay? Then from there now, this C2, then this 2 times 2 here, 2 times 2, so which is just 4. So this is H4, then O2. So now we can convert this one to a nice formula. So start with now including the functional group. So you know that from these 2 carbon, I've removed 1, so I remain with 1 here. And then from this 2 hydrogen, I removed 1 hydrogen, so I'll remain with 3. So just get this and add it before this one. Okay, so that's the formula for ethanoic acid. So we include it into the table. Is C3COOH. Now, what about propanoic acid? So prop means 2. So prop equals 2, and therefore our N is 2. So CnH2n or 2. So this is going to be prop means 3. So my bad. So you're going to put 3 there, then 2, that, and or 2. So now what you do there is 2 times 3. So I'm just saying 2 times 3. 2 times 3 there, just 6. So it's going to be C3H6, then O2. And this now convert it to the original formula. Now start with the functional group. So the oxygen are these 2 there. Then the carbon, remove 1 carbon, which is this one. So you remain with 2 carbon. Then from the hydrogen, remove 1 hydrogen. Okay. Remove 1 hydrogen, so you're going to have 5. So just bring this one into here. Okay. Yeah, so 2. Okay. So that's what you write there. So C2, C2, H5, COOH. Okay, so I'm going to give you a task. I'm going to give you a task. Can you try to do for butanoic acid, and then you comment in the comment section below. If you're watching in YouTube, or if you're watching using YouTube or Facebook, just let me know what the answer is. Okay, so from there now we move on to the second one. So let's look at the structural formula. So when you're looking at structural formula, we are looking at the same thing that I have for methanoic acid, for example. Methanoic acid, which is the molecular formula of HCOOH. Okay, so what is the formula? So the formula is the functional group, this one, then the oxygen has a double bond there, and then this one with the OH. And then now you can just include the H, the last part. Now remember that these are derivatives that are coming from the alkanes, okay, or the alkenes. So these are derived compounds. These are called derived compounds. So this is the structural formula, okay. Now what about ethanoic acid? So we know we have, you can just take that, we have written that, so CH3COOH. So this one, so you always start with this structure, the functional group. So it's going to be C, this one, and this one. And then you put another carbon to this carbon. It's going to be that. And then you attach 3 atoms of hydrogen. So here, here, there. So you have this. Okay. So this is the formula. The structure formula. What about propanoic acid? Propanoic acid. So this one is, we had this one as C2 H5 COOH. So into the formula, this one is just going to be, you start with this, so you'll be like this, okay, and this. Then you include 2 carbon of atoms. So this, then this. Then now you put in how many hydrogen? 5. So 1, 2, 3, 4, 5. So you just do this. Okay. So as simple as that. So you can only understand this if we are practicing, okay? So let us now advance now. So let us move on. So we are also going to look at how to make ethanoic acid. So how to make ethanoic acid? Okay, so one of the known and best example is, or method is, through oxidizing. Oxidizing what? Ethanol. Now this ethanol is an alcohol, okay? Now you have to go and revise the video that I did on alcohols so that you can sort of just understand that. Okay, so this is normally referred to as acid fermentation. Okay. Okay, so what are we saying? So ethanol is just written like CC, so carbon, hydrogen, then OH. Okay. Now what's going to happen is we are going to oxidizing this ethanol with the oxygen, okay, in order to produce ethanoic acid. Now, how is this happening? So what is happening is that we are adding this oxygen to this, okay, this part. So we are adding the oxygen to this part. So now this will give us sort of like C, okay, and okay, and then now because there is an addition of oxygen, so we are going to have 2 oxygen there. So this now will give us that, and at the bottom they are going to have okay, so going to have this. So okay, so this we have formed ethanoic acid by fermenting this ethanol. Okay, so moving on. So we are going to look at ethanoic acid typical acid reactions. Okay, so under this one, we talked about the a solution of ethanoic acid normally turns, so it turns litmus paper red. Okay, so it turns that one to red color. So that is sort of like this is an acid. Okay. Okay, so it also contains hydrogen ions Okay, so first of all, the solution of ethanoic acid turns litmus paper red or turns litmus red. And then also, it also contains the hydrogen positive ions because some of the ethanoic acid molecules dissociate. So to dissociate is just to dissolve, okay, in water, okay. So once if you look at dissociation, okay, when you are looking at dissociation of this ethanoic acid, okay, okay. So what you are looking at, if you have this ethanoic acid, CH3COO, okay, and then we dissolve it into water, okay. So what's going to happen is that from the functional group, the hydrogen will actually dissociate, okay. So what you remain with is CH3, then that, okay, leaving it a negative. So this is aqueous because we are dissolving, plus the hydrogen ions. So what we mean by this, what you see is on the paper, but in the actual sense now is that there is many of these hydrogen ions that are moving freely in water right there, okay, and also part of this. So it is a weak acid because the other part of the hydrogen have remained, okay. Now the other interesting part is that ethanoic acid, okay, so ethanoic acid reacts with metals, bases, and carbonates to form salts. So let us look at the simplest one where ethanoic acid react with, let's say, under metals, we pick sodium, okay. So we are going to have this. Okay, so when you pick now sodium metal, and this sodium metal is going to react with ethanoic acid, so plus okay, so we're going to react this sodium metal plus ethanoic acid. Now you remember very well that ethanoic acid is written like this, C. Okay, so that is our ethanoic acid. So since this is an acid, then it's aqueous, okay, then plus the sodium, okay. So I'm gonna actually, it's not really sodium, but okay. So let's say to react with metal, sodium. Okay. What is going to happen is that what is hydrogen there replace with sodium, and then we are going to have something like the sodium ethanoate. Okay, now this sodium metal has actually replaced the hydrogen, so you're going to have the hydrogen there. Okay, so this is basically simple equation. So this sodium ethanoate is normally called a salt, okay, or simply sort of organic salt. Okay. Now, the most important equation that I want to show is this one, where now we react with, let's say, ethanoic acid. The ethanoic, ethanoic acid plus sodium hydroxide. So this is a base, then this is an acid. Okay, and then what's going to happen is we are going to have a salt plus water. Okay, plus water. So we are going to say C, this is ethanoic acid, okay, okay, and then sodium hydroxide. So this is now going to be, now I want you to pay attention. What's going to happen is that this okay, so what's going to happen is this hydrogen is going to be replaced with sodium. Okay, so then we are going to have this OH, okay, and then this the hydrogen plus this OH, okay, so this is going to form H2O, water. So that's what we are going to have. So we are going to have something like H2O. Now, once you have H2O, then this hydrogen is going to be replaced with sodium. So what you're going to have is this. Okay. Then this, you're going to have O, then to be replaced by sodium. And then here we fill up this part. Okay. Then now we are going to say plus. Okay. Now you can see that what we have now, this one is, because of this metal, we are going to call it sodium ethanoate. Okay. Then that is water, of course. Okay. So what you need to understand is that when a base reacts with an acid, we are going to have this is a salt and this is water. Now, in organic chemistry, under organic compound, this salt is simply called an ester. It's called an ester. Okay. Okay. So we see in a more practical sense what that means. So just keep watching, and let's move on to the last part, where we are going to look at this organic acid reacting with organic alcohol. Okay, so this is the same equation that you normally get when, for example, if you can pick any mineral acid, for example, hydrochloric acid plus, for example, the same thing, sodium hydroxide, and then we are just going to get, this is going to be this hydrogen and OH, they are going to react together, then they are going to form H2O. So it's the same thing as we saw above here. So now this is a inorganic, okay. This is a inorganic, okay. Inorganic compound, or should I say, okay. So meaning that this chlorine and sodium are going to react, so then I'm going to have that. Now this part is what we call a salt, okay, and this is water. So now the same thing normally happens when it comes to organic chemistry. So we are going to have now, let's have let us have ethanoic acid, okay. And now plus we're going to have now this, okay, plus ethanol, okay, plus ethanol, So yeah. So this is a propanol, okay. Then this is ethanoic acid. So the most important thing is that what will be formed, okay, is that this, from the acid, we are going to get this hydrogen, okay, and then it will react with this HO or OH to form actually water, okay. Let me just drop it. So because of space, so it's going to form. So we are going to remove this hydrogen, and then the rest of this part will be just dropped down. See? Okay. And then from this part, you're going to get this one, okay? The whole of this thing. So just join from this part. Okay. And then we know that this, okay, this and this reacted together to produce H2O. Okay. So the most important thing to understand is how to go about this chemical reaction or chemical equation. So from there, then now we can name this compound. So this is one thing, okay? This is one thing. So how do you name this thing? Okay. So when you're naming this one, you always start with the alcohol part. Okay. So the alcohol part is propanol. So we're going to score it. Propyl. Okay. And then you end with the acid part. Okay. So propyl ethanoate. Okay. Ethanoate. Now you can take note that this product is normally also called an ester. Okay, so this is an ester, and the way you can note that this is an ester is because they always end in ATE. So they end in ATE. Now the ester group is this part, okay? The ester group is this part, and this can be recognized as COO. Okay, so that is an identification of the functional group of an ester. So this, okay, that's how you can know that this is an ester. Okay, so thank you so much for watching. If you have not subscribed, please make sure that you do subscribe to my channel for more information. This is Radko Academy, and this is Mike Wara. I'll be able to see you in the next video. Thank you so much.